Hello, my name is Prud'hommeaux. I'd like to talk about some work going on at Mayo Clinic, W3C and HL7 on representing FHIR in RDF and validating that with the schema language called shape expressions or SHEX. I'm going to give you a quick idea of FHIR and how it's defined and how it's represented. Next, I'll introduce a schema language for FHIR called shape expressions. And finally, I'll describe how it's used in a workflow for developing standard exchange formats. FHIR stands for Fast Healthcare Interoperability Resources. It consists of around 120 health-related or healthcare-related resource definitions, which are like observations, patients, medication administrations, medication orders, etc. It has a REST API, which means you can use HTTP to get and post and put it, and there are also SOAP wrappers and that sort of thing available. It's under Open Agile Development under the HL7 standards umbrella, and it has effectively a meta model, a schema language, and representations of the various things that you represent in that meta model, and tooling to help you publish those and validate them. So the FHIR homepage on hl7.org/FHIR provides you with a set of resources, which are standard documents for clinical exchange. Those are the things that I was talking about, the observations, patients, medications, orders, etc. This page allows you to navigate the standard as well as proposed changes. So for instance, you'll see that at the top it says resources, which allows you to get around in the standard. Down a little bit, you'll see DSTU2, and that tells you what the status of the standard is. At the bottom, you will see propose a change, which allows you to say, I think you made a typo here, or this needs to be fixed, or it doesn't address your community use cases. The most used clinical need is to capture clinical observations. So we will look at observation. By clicking on observations and then scrolling down a little bit, we see a logical model of an observation. This says that an observation has 0 or more identifiers. Note the 0 to star right here. Exactly one status, etc. The value of the status property is a code. We see that right here. The value of the category property is a codable concept, which is like a 21090 CD. And the value of the subject property is a reference to a patient, a group, a device, or a location. Each of these structures is defined with its own resource page. You will see that everything's clickable, and so when you click on that, that takes you to those definitions in turn. The effective X link that you see here means that you have a choice. You can have either an effective date time or an effective period, and both of those properties reflect the value type that they're expecting. Resources can be viewed so you can click on any of these things in order to go to the resource. So they can be viewed in this structure definition, this structure layout, or in UML, or in XML and JSON templates. These templates provide documentation by example. The idea is that you will copy a template and modify it for your needs. Examples, see the note at the top that always has links to examples, are available in the same formats as the templates. So for instance, XML and JSON. So this is an example of a FHIR observation resource expressed in JSON. So what is JSON? It's a very simple model that has hash maps, arrays, and scalars. The scalars include strings, numerics, true, false, and null. JSON has some good attributes. No modeling is required. It's easy to learn. It's built into JavaScript, which means it's in every browser, which is great. And parsers are available for every programming language. Now, getting back to the no modeling required, that means there's really no modeling built in. There's a JSON schema emerging, but it's kind of slow going. So, looking back at the observation example again in JSON, we see hash maps with the curly braces. So there's a beginning of a hash map, there's the beginning of an array with the square braces, and then literals show up in the scalars show up in quotation marks. So given the amount of clinical and biological information that's available in RDF, it seems like it would be nice to have an RDF format for FHIR. So recent collaboration between HL7 and W3C gives us just that. The FHIR resources homepage gives us a link to the directory of published versions. The current version, if you click on the current, gives you, that's the one that's under Agile, active in Agile development under GitHub, and it includes FHIR RDF expressed both in Turtle and then an RDF format called JSON-LD. RDF's data model is actually even simpler than JSON's, with triples of subject relationship object made up of URLs, literals, and an anonymous node called a blank node. Here we've written the triples out as English with angle brackets around them. You'll see Bob is a person, Bob is a friend of Alice, etc. So the things that are in angle brackets would be expressed in a single term. Turtle's notation is, here we see some actual RDF written in a format called Turtle. And Turtle's notation is effectively the RDF abstract syntax plus some syntactic sugar to make it make multiple assertions about the same thing very easy to write. So you could say Bob, you could say an observation had a status of this and had a code of that. So where are we with FHIR and FHIR RDF? So it's still under development, but it's nearing stability. The rule is the RDF format must be completely round trippable to JSON and LD. So you can go to one and go back to the other and get exactly the same thing. We work a lot with examples, but the examples are, in order to manage the examples, we have to make sure that they are valid, so we're using a language called shape expressions. So at the bottom of every table of these tables, you see there's a link to the XML schema, and there's also checks or shape expressions for the RDF representation. Here, the schemas are available. So here we see a mapping from FHIR for observations and the checks, which corresponds to that. So on the left is the FHIR representation, and on the right is the checks that make sure that you've actually represented that stuff correctly when you're writing it down in Turtle. So to give you a quick example of what that looks like in use, here I've written a bit of, I've taken a piece of the FHIR observation schema on the left and the FHIR, an example of the FHIR observation on the right, and validated it. And so suppose I were to break that validation, suppose I were to change the status to status 999, then we would see that that it expected at least one match of FHIR observation status matching a shape code. And so we didn't actually give it that, but we can fix it, and we will go back to having a valid instance. Thank you very much for your time, and we'll be glad to talk to you more about shape expressions in RDF and FHIR.